to simplify rational expressions. So the first thing that we need to look at is, what is a rational expression? And if we start, first of all, with the rational number. What is a rational number? Well, a rational number is any number that can be written as a fraction. So a rational expression is still going to be something that's going to be written as a fraction. But what happens with a rational expression is that there's a variable in the numerator, which is the top of the fraction, and there's a variable in the denominator, which is the bottom of the fraction. And to simplify a rational expression, what we need to do is we need to factor as much as possible. And once we factor as much as possible, we'll look and see, does anything cancel out? Typically what I say with the canceling out is, do we have anything that's exactly the same on the top and the bottom? So let's take a look at our first example here. And we have 9x squared minus 2x divided by 9x minus 2. Can we factor anything in the numerator, the top of the fraction? Not much, but we can factor out an x. We have a greatest common factor of an x. Remember to figure out what remains in the parentheses here. We can take 9x squared divided by x, which is 9x. We had 2 x's, we took out 1. 2x divided by x is 2. We had 1x, we took it out. It's out in front. So we factored out the numerator there. As we take a look at the denominator, the bottom of the fraction, we cannot factor anything out of there. We don't have a GCF. But to finish this problem, what we need to ask ourselves is, do we have anything that's exactly the same on the top and on the bottom? Well, 9x minus 2 on the top is the same as 9x minus 2 on the bottom, and we can cancel those out. One thing to keep in mind when we do cancel those out is that 9x minus 2 divided by 9x minus 2 is 1, and what we're really left with here is just 1x. Now we were lucky enough on that first problem to be able to factor out something in the numerator, but we don't have to factor out anything in the numerator. As we can see in this problem on problem number 2, nothing factors out of the numerator, the top of the fraction. But if we look at the bottom, our denominator of our fraction here, we happen to have a greatest common factor of x. And when we factor out an x squared divided by x is x. 6x divided by x is 6. And then what we need to ask ourselves is, do we have anything exactly the same on the top and the bottom? And some people might be thinking, no, we don't have anything. But what we really do have is, we happen to have an x in the numerator and an x in the denominator. And we can cancel those out. X divided by x is 1. And we're left with our remaining values there of 3 divided by x plus 6. Factoring is the key here. We need to be able to factor. And on problem number 3, as we take a quick look at the numerator, it looks like we might be able to split the middle on our numerator. And remember, here's A and here's C, kind of right off to the left on your paper so that you've got enough space. And 1 times 12 is 12. And the factors of 12 are 1 and 12. And 2 and 6, and 3 and 4. Will any of those combine to be 7? Pretty equal. So when we go back in here, we've got x squared and we've got plus 12. We're splitting the middle this time. Luckily enough, it's going to be plus 3x and plus 4x. We don't have to worry so much about our signs because everything's going to be positive. And then we split the middle. Well, our greatest common factor in our first group is x. And we're left with x plus 3. We had 2 x's, we took a 1 down. 3x divided by x is 3. In our second group, our greatest common factor is a 4. 4x divided by x is 4. 12 divided by 4 is 3. And finally now, we see, I hope, that there's an, and you're looking at me funny, sorry about that, there's an x right there. 4x divided by 4 is x. But we've got an x plus 3 in each group. So we have x plus 3, so that I have it written correctly, and we have an x plus 4. That's our numerator. That's the top of our fraction simplified. We can't do anything to our denominator. I need to scoot it back up to see what the denominator was. It's an x plus 3. But do we have anything exactly the same in the top and in the bottom? And we've got an x plus 3. Remember, x plus 3 divided by x plus 3 is 1. And typically we don't have to write that. It's 1 times x plus 4, and 1 times x plus 4 is just x plus 4. The key to simplifying rational expressions is factoring. You need to be able to factor. And in problem number 4, we need to factor the numerator, the top of the fraction, and we need to factor the denominator, the bottom of the fraction. What's our greatest common factor in our numerator? It is factor out of 2. 8 divided by 2 is 4, and 2x divided by 2 is x. And I wrote it up there beside here, because eventually what's going to happen is in the bottom of our fraction, in the denominator of our fraction, we'll fill in something in that format. But once again, we're going to have to split the middle of x squared minus x minus 12. The nice thing is that on the last problem, we had to factor 12, and we have to factor 12 on this one also. Factors of 1 times 12, 2 times 6, 3 times 4. We're going to split the middle. Then we have x squared, and we have minus 12. Well, will any of those combine to be 1? And the answer is 3 and 4, once again, but we really need to get negative 1, and to come up with negative 1, it's going to have to be 3 minus 4. So plus 3x minus 4x. And it doesn't matter if you wrote minus 4x first and plus 3x second. It doesn't make any difference. We need to find our greatest common factor from each group. And in our first group, we have a greatest common factor of x. We had 2 x's, we took out 1. We've got 1x plus 3. X squared divided by x is x. 3x divided by x is 3. Be careful over here in the second group. Some people are really missing the factoring because they aren't writing down that negative sign. Because not only is our GCF 4, it's negative 4. And negative 4x divided by negative 4 is positive x. And negative 12 divided by negative 4 is positive 3. And what we can see here is that there's an x plus 3 in the first group, and there's an x plus 3 in the second group. And then our singles that are remaining are the x times 4. When we fill those back in, x plus 3 and x minus 4. Now, I didn't do very well with my space here, and hopefully you can squeeze a little bit more in here, because do we have anything exactly the same on the top and the bottom? And we don't have anything exactly the same. This is positive 4, and in the bottom we've got negative 4. Up top it says minus x, and the bottom it's just x. What we have is we have almost the same on the top and the bottom, but not quite. What we can do when we have that kind of situation is we can change everything to the opposite sign. And I'm only talking about the top part here of what we want to change. So it's not coming out very well. Let me try this again. Let's change our sign on the 2 to negative. If we change our sign on the 2 to a negative, we need to maintain the same value on the top of our fraction. So we need to change our sign on the 4 to negative, and we need to change our sign on the x to positive. And look what just happened. If we distribute that negative 2, negative 2 times negative 4 does give us positive 8, the value that's back in the original problem. Negative 2 times positive x gives us negative 2x, the value that was in the original problem. We didn't change any value in the original problem, but we did have to change a couple signs. And as I squeeze this in here, we've got x plus 3 and x minus 4. Well, what happens now is, and some of you can see, do we have anything exactly the same on top and the bottom? Some of you say yes, and some of you are like, I don't know. So as I scoot down under here, then this is negative 2. But in the parentheses, I'm going to write x minus 4. Oops, I want to make that a green 4. But all that we did here is we just changed the order. We wrote the x first, and the sign in front of the x was positive, so we didn't have to write the positive again. And by writing it in this format, it may be a little bit easier for some to see, do we have anything exactly the same on the top and on the bottom? And now you can clearly see we have an x minus 4 on the top, and x minus 4 on the bottom. And when we divide those out, remember x minus 4 divided by x minus 4 is 1. We will end up with negative 2 divided by x plus 3 when we simplify that entire fraction. As we finish our last two, once again, the factoring is critical. If we can get this factored correctly, we can probably simplify our rational expression. But if we can't factor, we may have issues. And I'm going to write this on top beside the fraction there to leave us a little bit of space to split the middle underneath the problem. You probably want to go left on your paper again. But how can we factor x squared minus 9? Well, it's the difference between two squares. X squared is x times x. 9 is 3 times 3. Difference between two squares, different signs. But we need to split the middle with our trinomial in the denominator in the bottom of the fraction. Eventually, we will end up in this format with those two parentheses. But to get there, we've got x squared and we've got 9. And remember, here's our a and here's our c. 1 times 9 is 9. and the factors of 9 are 1 and 9, and 3 and 3. Will either of those combine to be 6? 3 and the 3. And in fact, it's going to have to be negative and negative. Minus 3x minus 3x plus 9. Thank you. So, now, our greatest common factor in the first. And x squared and 3x is x. And we're left with x minus 3. X squared divided by x is x. 3x divided by x is 3. Once again, watch out for that sign. Because it's negative 3. And really, we better get the same value in the second parentheses that we got in the first. Negative 3x divided by negative 3 is x. Positive 9 divided by negative 3 is negative 3. And we get x minus 3 times x minus 3. We've got the x minus 3 in the group, and then our singles turn out to be x minus 3 as well. When we go back and fill that back into our denominator, do we have anything exactly the same on the top and on the bottom? One of the x minus 3's. Remember, x minus 3 divided by x minus 3 is 1, so we don't have to write that. But we do want to write down what's remaining, which is x plus 3 divided by x minus 3. As we finish, I'm really sorry, I don't think I left enough space on problem number 6. Because we need to split the middle for both of them. We're going to split the middle for x squared minus 7x plus 10. Then we're going to split the middle for 3x squared minus 8x minus 35. We need to split the middle for both. For our x squared minus 7x plus 10, it's not too bad. The a times c is 10, and the factors of 10 are 1 and 10, and 2 and 5. Will either of those combine to be negative 7? Combine to be 7? 2 and 5. And in fact, it's going to have to be negative 2 and negative 5. So we've got x squared and the plus 10, and then we've got minus 2x minus 5x. Remember, it doesn't matter. If you wrote minus 5x first and minus 2x second, it doesn't make any difference. But we are going to factor here. And our GCF in the first group is x. And then we've got x minus 2. We had 2 x's, we took 1 out. Our GCF in our second group is the 5. And we're going to be left with x minus 2. In fact, it was negative 5. Negative 5x divided by negative 5 is x. Positive 10 divided by negative 5 is negative 2. And in each group, we've got an x minus 2. And then our remaining values are x minus 5. So that's the numerator of our fraction, the top of our fraction. We need to go through the same process with our denominator. We're trying to figure out if we even have anything that's exactly the same in the top and in the bottom. But in this one, 3 times 35 is 105. And our factors of 105 are 1 and 105, 3 and 35, 5 and 21, and 7 and 15. will any of those combine to be 8? I think 7 and 15. And in fact, it's going to have to be plus 7 minus 15. So we've got our 3x squared and our minus 35, squeezing this in. It doesn't matter. I've said it before. I mean, we can say minus 15x plus 7x. I typically go in the same order that I have it written down, but it doesn't make any difference. Might be a little bit easier if you can write the plus in between that first and second group. But in our first group, the GCF between 3 and 15 is 3. Between x squared and x is x. And 3x squared divided by 3x is x. 15x divided by 3x is 5. Over here in our next group, when we factor out the 7, the GCF, we're left with x minus 5. 7x divided by 7 is x. 35 divided by 7 is 5. And when we simplify our denominator now, denominator of our entire rational expression, we have x minus 5 and 3x plus 7. So when we put this all together here, and I'm really sorry because I know that I probably didn't leave you enough space. X minus 2 divided by x, or times x minus 5 is what we have in the top when we factor our numerator. X minus 5 times 3x plus 7 is what we get when we factor our denominator. And lastly, do we have anything exactly the same in the top and in the bottom? Well, we have in x minus 5. And x minus 5 divided by x minus 5 is 1. And we are finished with this problem. If I can write it correctly, we're finished when we write x minus 2, what's still remaining, and then 3x plus 7, divided by the 3x plus 7.